Theorems on limits. Theorem 1. If f of x is a polynomial in x, then limit f of x as x tends to a equals f of a. Example, limit x plus 2 over x minus 1 as x tends to 2 equals 2 plus 2 over 2 minus 1 equals 4. If the answer is an unspecified quantity, some more work like factorization, multiplication by the conjugate, or long division, has to be done. Result. If k is a constant, limit of k as x tends to a equals k. K belongs to the set of real numbers R. Example. Limit 3 over 7 as x tends to 2 equals 3 over 7. Theorem 2. If f of x and g of x are two functions in x, then 1. Limit f of x plus or minus g of x as x tends to a equals limit f of x as x tends to a plus or minus limit g of x as x tends to a. 2. Limit f of x multiplied by g of x as x tends to a equals limit f of x as x tends to a multiplied by limit g of x as x tends to a. 3. Limit f of x divided by g of x as x tends to a equals limit f of x as x tends to a divided by limit g of x as x tends to a. 4. Limit kf of x as x tends to a equals k limit f of x as x tends to a, where k is a rational number. In this example, find limit of x power 2 minus 9 over x minus 3 multiplied by square root of x plus 1 minus 2 over x minus 3 as x tends to 3. According to Theorem 2, the limit of the product of two polynomials equals the product of the limits of the two polynomials separately, as shown. Substitute x by 3 in the first polynomial. The answer is the unspecified value, 0 over 0. Factorize both numerator and denominator, we get limit x minus 3 times x plus 3 over x minus 3 as x tends to 3 equals limit x plus 3 as x tends to 3 equals 3 plus 3 equals 6. On the other hand, substitute x by 3 in the second polynomial. The answer is also the unspecified value, 0 over 0. Multiply both numerator and denominator by the conjugate of the numerator, we get limit square root of x plus 1 minus 2 times square root of x plus 1 plus 2 over x minus 3 times square root of x plus 1 plus 2 as x tends to 3 equals limit x plus 1 minus 4 over x minus 3 times square root of x plus 1 plus 2 as x tends to 3 equals limit x minus 3 over x minus 3 times square root of x plus 1 plus 2 as x tends to 3 equals limit 1 over square root of x plus 1 plus 2 as x tends to 3 equals 1/4. Final answer equals 6 times 1/4 equals 3/2. Theorem 3. If f of x and g of x are two functions in x, f of x equals g of x for all values of x except at x equals a, and limit f of x as x tends to a exists, then limit g of x as x tends to a equals limit f of x as x tends to a. Theorem 4. Limit x power n minus a power n over x minus a as x tends to a equals n times a power n minus 1, where n is a real number. In this example, limit x power 6 minus 64 over x minus 2 as x tends to 2 equals the unspecified value 0/0. In the numerator, as x has the power 6, we convert 64 to 2 power 6. Apply theorem 4, where n equals 6. The answer equals 6 times 2 power 6 minus 1 equals 6 times 2 power 5. Corollary of theorem 4. Limit x power n minus a power n over x power m minus a power m as x tends to a equals n over m times a power n minus m, where n and m are real numbers. In this example, limit x power 4 minus 81 over x power 3 minus 27 as x tends to 3 equals the unspecified value 0/0. As x in the numerator has the power 4, we convert 81 to 3 power 4, while as x in the denominator has the power 3, we convert 27 to 3 power 3. Apply the corollary of theorem 4, where n equals 4 and m equals 3. The answer equals 4/3 times 3 power 4 minus 3 equals 4/3 times 3 equals 4. Solved exercise on theorem 4 and its corollary. Exercise 1. Limit x plus 3 all power 7 plus 1 over x plus 4 as x tends to -4 equals the unspecified value 0/0. In the numerator, as the bracket x plus 3 has the power 7, we convert 1 to 1 power 7. Apply theorem 4. Where n equals 7. The answer, 7 times 1 power 7, minus 1, equals 7. Exercise 2. Limit, x power 2, cubic root of x, minus 1, over, x power 3, square root of x, minus 1, as x tends to 1. Equals the unspecified value, 0 over 0. As x in the numerator, has the power 7, over 3, we convert, 1 to 1 power 7, over 3. While as, x in the denominator, has the power 7, over 2, we convert, 1 to 1 power 7, over 2. Apply the corollary, of theorem 4. Where, n equals 7, over 3. And m, equals 7, over 2. The answer, equals 7, over 3, divided by, 7, over 2, times 1 power 7, over 3, minus 7, over 2, equals 2 over 3.